So what
Okay.
we've done on power is we've focused on consolidating, or both making the facility able to be more dense on the IT side as well as more dense on the mechanical and electrical side. So whereas a typical facility is 50 or 60% dedicated to mechanical and electrical, as high as sometimes 70%. We're at right about the 20% number, and we've done that by taking some manufacturing, taking your normal data center equipment and looking at what they really do, and instead of going to your typical data center vendors, going out and looking at what some of the mission critical manufacturing plants, like major chip manufacturers who, if they have outages or whatnot, cause serious dollars lost because of having to recertify, etc. So we looked and saw what type of vendors they were using, and they still have battery backups, and they still have the same type of mission critical infrastructure that a data center does. But long ago, because they're using so much power, that you've got like an Intel plant I've heard uses as much as 80 megawatts of power. Because they use so much, it doesn't make sense for them to put that infrastructure inside and take down their manufacturing space. So long ago, they started expanding outside, and we've had NEMA 3 enclosures that for years. I mean, your major electrical substations, they're all outside. Electrical gear outside is not a big deal. It's your standard procedure for all the power companies. So we went and we took all of the infrastructure that normally sits inside, or sometimes sits inside data centers, and took that out, and that really grew our white space. On the power levels, we actually feed from 2 separate transformers on a substation. We trench redundantly in on an A and a B trench, keeping at least 10 feet apart at all times. We trench redundantly all the way in and feed a completely separate A and B system. Each system is 10 megawatts of A and B power, fed from both substations. And what that means is if I for some reason lost my A UPS, at the same time I lost my B transformer and electrical feed, the A transformer would feed the B UPS, and you would still be N+1 protected. So each transformer feeds into the SES, which is built into the SNC gear. The SNC gear each accept 3 inputs: an A feed, a B feed, and then the generator feed. The generators, we split the bus, and we have N+1 on either side of the generators. We chose to split the bus so that if for some reason we ever lost multiple generators on one side, we could combine the bus if we chose, and let some generators from one side act as the redundancy for others. And we have multiple failure modes on that. I think we're about 80 failure modes deep now. That if we were to lose a certain number of generators, we could lose certain sections of the facility. So if we lost generators 1, 3, 9, and 5 or whatever, we might only take down a small section versus dropping the entire load. And that's been a very complex process for us, but something that we felt was very important. Leaving the UPS, we actually loop feed our distribution transformers. That way there's no single point of failure there. And from there we feed into what we call PDBs. Because really a PDU is simply a panel, a couple panels, a transformer, and some monitoring in a very pretty, very expensive box. And what we've done is we've taken that large PDU and we've shrunk it down using what's called an integrated switchboard, a product that they've used in manufacturing for years. And it's a much smaller vertical implementation of basically a PDU. So again, this is transformer monitoring of every single branch circuits in the mains, and a panel board in a 3x3 foot box. And we distribute that down what we call our power alley, straight down the middle of the data center to cut down runs.